Thank you for watching Knowledge Academy. Okay, in this chapter, we're going to talk about motion in a straight line. Before we start motion in a straight line, we need to talk about when we talk about motion, is confined and constrained in a straight line means is very, very restricted. Do not do anything else but to follow a straight line path. We also use a typical word in the industry called linear motion. Before we jumping into linear motion or motion in a straight line, we're going to talk about where these motions are located in overall in physics. So let's talk about this slide. This slide we are mentioning physics. Physics have a too many branches. Physics is a very diverse topic or subject. We're going to talk about four very diverse topics are optics, which is a study of light. Second one is mechanics, which is a study of motion. And this is one of the most oldest branch of physics. The other two branches of the physics is electricity, which talk about electron flow, charges, quantum, and the last one is heat, the flow of energy from one location to another. In this chapter, we're going to focus on number second, which is mechanics of motion or motion in a straight line. Now, when we talk about motion, the two things come in our mind. What causes motion? And the second one is what happening during the motion. Okay, for example, I have a table. Okay, I have a table and I'm putting an object on the table. Let's suppose object on the table. And what I'm asking, I'm just pushing this object on one end, applying the force. Now this block or this box is trying to displace, moving in this direction and move to this direction. Now I can assuming the location A to B. Now A to B is moving into a straight line, so I can consider this is a linear motion because it's a linear in one direction. Okay. We can also call motion in one direction, linear motion or motion in one direction. So it could be motion in this direction. If you want to drop a box gonna come down. So motion will be down direction. So motion could be right, left, up, down. The condition is gonna be only straight line or linear motion. Straight line motion or linear motion is pretty much the same thing. The second thing we're going to be discussed later in those chapters, not in this chapter, what cause of motion. So I'm using force to push the block. I'm going to discuss force in the preceding chapters or upcoming chapters. In this chapter, we're going to be talking about what's happening during the motion. Means block is moving. So from where to moving? Moving from A to B. Okay. And this study also called kinematics. So kinematics, linear motion, and motion in a straight line, pretty much all motion in a straight line. These all three are pretty much same thing, have a different name. Okay. So let's discuss and focus on kinematics or linear motion, motion in a straight line. You can see here the left side of the image. There's a gear and a pinion. We're moving in one direction. This is a great example of motion in a straight line. When we talk about motion in one straight line, we can also call one-dimensional motion, right? One-dimensional motion or 1D motion. In the following chapter, we're going to be talking about 2D motion and 3D motion as well. Okay, but at this point, we're going to discuss about 1D motion. And following chapter, we're going to discuss very detailed about 2D motion. Three-dimensional motion is much complicated. We may not be discussing too much in this course, but it can be done in the same way like we're discussing 1D and 2D motions. Before we jumping into details, we're going to talk about a bunch of different things in one-dimensional motion. The first one is time. What is time? Time is a duration, right? Time is a duration. For example, this car is going this direction, and this car is going to be reach out to here. I can just make this car like this. I can call this is A, this is B. Let's suppose you have a stopwatch in your hand and you measure when car actually started here, the time was 0 second. And when the car is reaching at point B, the time on the clock watch is maybe 30 seconds. So you can say here, it took this car T1, 0 second, T1 or TA, TB or T2, we can call it 30 seconds. So you can call delta T, which is T2 minus T1 equals to 30. So basically this car travels from point A to B in 30 seconds. So time is the duration required to complete the event, or time is required to any event took place during that duration. Okay. Let's talk about the distance. Okay. Let's talk about the distance. Distance is basically when you try to travel, you follow the path. So when you follow the path, and this path called displacement. If it's in a straight line, if it's not in a straight line, called distance. For example, that's your school, and you travel every day from between school to home or school to work or any other location. You go this direction, making a right turn, making a left turn, comes down, go all the way down, and you get to the destination or reaching over here. Now, in this case, all the distance you travel from here to here to here to here, this is called distance. One interesting thing about distance is it may or may not be in a straight line. Having said that, when I say it's not in a straight line, so let's suppose you travel from here to there is 5 meters, here to there is 2 meters. So I'm going to just make these arrows. From here to there is also 2 meters, here to there is 1 meter, and here to there is 9. So someone asking you how much you travel from your school to home, simply you can say distance. 5 plus 2 plus 1 plus 1 plus 9. I simply add on. It's going to be 7, 8, 9, and 18. Okay. Now, while we're talking about distance, let's move on to speed. Okay. Speed is how long it takes to complete a particular distance. So basically, you're saying it takes you how much distance covered in how much time. So really, speed is nothing but it's just the ratio of distance over time. Okay. Let's suppose in this example, let me add something here. You take 5 meters and it took you 3 seconds. This one takes you 0.5 seconds. This one takes you 0.5 seconds. This one is taking you 1 second. This one is taking 7 seconds. So how much total time it took you to get to the destination? So time from school to home is equal to 3 seconds plus 0.5, 0.5, so 3 plus 0.5 plus 0.5 plus 1 right here, and plus 7. So 3.5 is 4, 5, and then 7 is 12 seconds. So what is the speed? Speed is nothing but distance over time. So you can simply say that here. Distance is equals to 80 and time equals to 12. So you can say 80. And if you divide it, then it's going to be 6, 3 over 2, or you can say it's 1 point. But the unit will be distance is in meter, time is in second. So the answer should be meter per second. Sometimes you can also write 1 meter per second. That is a display. This is a speed. That's your speed. Okay. Now, the same way you're writing distance, I'm going to talk about displacement. Displacement is basically should be straight line. Is always in a straight line, and it's the shortest distance. Shortest distance. So really what you're going to do here in this case, you're going to be asking, if somebody asking, what's the shortest distance to go from school to college? All you have to do just making a line. Okay. And this line from here to there, this line, the one I'm just passing the cursor, the red color line, put it here. You need to just asking how long is the line, and basically should be in a straight line. And let's suppose you take the ruler and measure it. This line is supposed to be come out something 5. You can say it's 15. Okay, 15 meters. So that's a displacement. So I'm going to be just writing here 15 meters. And that's my displacement is placed in a straight line. And what is the velocity? Velocity is nothing but velocity. I'm going to say here velocity is displacement over time. Since it took a straight line, right, to draw the straight line, definitely you also need the different time. So let's suppose a time here, this could be from, if you want to draw, if you want to fly, let's suppose you drive by road, and if you drive, you go like this way. And if you want to ask into about flying, and you want to fly, you just fly straight. So when you fly straight in a straight line, displacement would be 15 meters. And from here to there, it took you some time. So let's suppose you say it's 5 seconds. Right, 5 seconds. So I'm going to write here, it took you 15 meters, it took you 5 seconds to travel. So if I want to substitute this 15 and 5 in the displacement in time replacement, so I'm going to say is velocity equal to displacement over time equal to displacement is 50, time is 5, and the answer is 3 meters per second. Just like speed, you can also write 3 meters per second. Yeah. Now, before we move forward, we're going to be talking about acceleration. Acceleration is a little bit different than the rest of the quantities. It is a little bit difficult to understand if you do not understand well all these 6 quantities, all these 5 quantities if we talk. So let's talk about the acceleration. Acceleration is nothing but is just another measure of how fast you change the velocity. So let me just make it simple. So when we're talking about acceleration, we are talking about nothing else but velocity. So just like when we're talking about the speed, we talk about distance and time. When we talk about velocity, we talk about displacement and time. But when we talk about acceleration, we can only talk about velocity and time. So think about it. If this car is moving 10 miles per hour, and then somehow this car actually, the driver actually pushed the gas, and this car is going really fast, and this car is reaching out to this point. In order to make the simplification, I can call this location as A, this location A, the car was going 10 miles per hour. The driver pushed the gas pedal, and the car is moving now 50 miles per hour. Okay. The velocity of the car here is 10. The velocity of the car here is 50 miles per hour. Since we are not using miles per hour, we can use standard unit. So maybe I can convert it. Just for assumption, I can make it to meter per second, which is making sense. In the previous chapter, we learned about SI system. And in the SI system, we always measure the velocities and acceleration and displacement in meter. So I'm going to say it's 10 meter per second. And here the velocity is 50 meter per second. In this example, simple as that. Now, how much velocity change? So I'm going to say change in velocity, which is delta equals to v2 minus 1. So v2 right now is 50 minus 10. And it's going to be 40 meters per second. That is my change in velocity, delta change in velocity. What is acceleration? Acceleration is how fast velocity change happens. How fast change the velocity. Just like in the previous example, I'm also need a stopwatch here. And I'm going to be checking the stopwatch and the stopwatch here. So when this experiment is started, you take the stopwatch, the time was 0 second. When this experiment over at point or location B, you look at the stopwatch and the stopwatch says 30 seconds, just like previously we used this example, so 0 to 30 seconds. So bottom line is that this car took 30 seconds to go from point A to B. Also, when the driver was driving at, very important point, driver was driving this car at 30 miles per hour or 10 miles per 10 meter per second at point A. And at point B, the driver was going 50 meter per second. What's happening in between? I don't care. What's happening in between? I don't care, and I don't even know about it. Because I'm only looking the system in this position and this position in order to find the change. In order to find the change, you always look the final position, and you also looking the initial position and minus whatever is the initial position out of the final position, and that's you get the change. Now, acceleration formula is pretty simple. How fast you change the velocity, it means change in velocity divided by time. And you call it acceleration. And the way you're going to be writing here is, in this example, change in velocity is 40 meter per second. Time is 30 seconds. So if you divide then 40 over 30, it's going to be 1.3, something like that. Now, pay attention on the unit. The unit will be meter per second divided by per second. So really it's going to be 1.333 meter per second. So that is acceleration. I hope you understand all these 6 terminologies. So what you're going to do, we're going to go in real quick, jumping and talking about the topics a little faster before we do the problems. So linear motion, we talk about that one. Motion is moving in a straight line. We talk about this called linear motion. Great example during the car, the race, the car race, the cars are going in the same direction or one direction, so they can, you know, basically they don't want to be doing all kind of turning effect, right? So we're going to be talking about position, displacement, and average velocity. So what is the position? I told you. The position is where you're located. The displacement is how much you move in a straight line. What is the average velocity? Average velocity means an object, just like the car, moving in this position A, and there is a car is moving in position B. The velocity was AVA is 7 meter per second. Velocity is 9 meter per second. So what you're going to do, average, you're going to take the average between the two. So say 7 plus 9 divided by 2. There's going to be 9 plus 7 is going to be 16 divided by 2. So answer is 8 meter per second. And what you're going to call it? V AVG. AVG means, usually we call average, is a symbol we use for that. Instantaneous velocity and speed. Instantaneous means now. It means here at VA, this is called instant. Instant. And here is also instant. So the word instantaneous came from instant. I already mentioned to you what is acceleration. Acceleration is nothing but is a change in velocity. What is a constant acceleration? It means you're constantly increasing velocity. Let's suppose you're constantly pushing gas. So if you keep going, if you keep getting faster and faster and faster, right? If you keep getting fast, let's suppose you go to the highway and what you do, you put the cruise on. When you put the cruise, your speed is constant or velocity is constant. So when you put the cruise, velocity is constant. So when your velocity is constant means delta V equals to 0 because you are basically, your car is going here, whatever speed, and after, look at the other point, like you put the speed at 80 or 70 miles per hour and then put the cruise on. It means car is keep going with 70 miles per hour. It means car velocity is not changing, and velocity is not changing, the changing velocity is 0. So acceleration equals to delta V over time. So time is 0, whatever time, you can put whatever time here, but the velocity is basically becomes 0, so acceleration equals to 0. So bottom line is that when velocity is constant, acceleration is 0. And when acceleration is constant means, when acceleration is constant, it means, constant acceleration means constant acceleration means velocity keep changing constantly. And I'm not going to say constantly keep changing, I'm going to say velocity keep increasing or decreasing constantly. Changing means increase or decrease. So I'm going to say this one. And we're going to talk about the free fall motion. Free fall means if something drop, and we're going to consider this as a free fall means if something dropping towards the earth, we consider them free fall. Okay. So let's talk about the position. We talk about position, but we don't talk about this thing. So position means, position can be, let's suppose this is a point you are, right? The object can be go this way towards the right, we consider positive. If you go towards left, we consider them negative. So if you have any object like there, and I say go towards left or go towards the right, you have to make sure you know that this one is positive, this one is negative. And why is negative and positive? Because you can remember this is x-axis, y-axis, and this guy is positive, and this guy is negative. So that is how the position is also negative or positive. So if someone says go to -3 meter location, so you're gonna say 1, 2, 3. So you're gonna go here. because I say -3 meter position. If I say go to +3 position, we're gonna go to 1, 2, and it's gonna go this side. Just like we mentioned, change in position called delta x, right? So if you are at 5, go to 12 meter. So what is delta? Delta is if you go to 5 and 12, so you're gonna say 12 minus 5 equals to 7 meter. Positive or negative? Look like positive because it's a positive 7 meter. It's a positive direction. But let's suppose you are at 5 and you have to go to 1. So let's suppose here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If I'm asking you, you was supposed to be at 5, x equals to 5, so you're gonna go here 1, 2, and we just 1. And I'm asking you move to location x equals to 1. So you're gonna say 1, 2, 3, you here. So really, you was here and now you are here. So which way you go? Right? You was at point A, now you are at point B. It means you are moving towards left. So how much you move? You move -4 meter. How it comes out? 5 minus 1 equals to 4. And how do you came with the 4? Because you go towards the left, so you need to put the minus sign to show that this minus sign you have to put yourself, so you can tell it is positive. Yeah. So in this thing, in the morning, a bird is in the Tampa, Florida. In the afternoon, the bird is in near Orlando, Florida. Give this information. Which of the following statement best describe the relationship between magnitude of the bird displacement and the distance of the bird travel? Okay. So I'm going to say the distance of travel is either greater or equal to magnitude of the Earth displacement. Because of things, let's suppose this is the Florida. I'm going to make the map like this. And this is a Florida map. So maybe Tampa here and Miami here. So this is Tampa, there's a Miami. And if the bird is going this way, maybe bird decided to fly straight line. Maybe bird flying here and coming here, maybe coming here, maybe coming here. But bottom line is that maybe bird is going in a straight line. If bird is flying in a straight line, the distance equal to displacement, right? Remember, we already talked about that. The distance and displacement are could be same if the distance is done in the straight line. So I'm going to say here, if the bird is flying in a straight line, then distance equal to displacement. But if the bird is not flying in a straight line, they go a little bit here and then come back. It means distance is bigger than displacement. Which could be possible. So I think it looks like this is the correct answer. Its distance could either be greater or equal to. Okay, that's the correct answer. Move on. We already talked about the average velocity. Another way you can find the average velocity is you take the total distance the things is traveling divided by time, and it's going to give you the average velocity. We can also draw the distance or distance and time graph, or you can call ds dt graph. Dt graph means distance and then time graph, dt graph. And there in dt graph, what you have to do is put the time on the x-axis and put the acceleration and put the displacement in the y-axis. And if you pick any point, that's what you call instantaneous velocity. And if you take the 2 point and divide it by the time, so what you're going to do, we take the x from here and x from here, and then says x2 minus x1 divided by t2 minus t1. They're going to give you average velocity. Same thing. Okay, let's take a look into this multiple choice question. I hope it's going to be simply a turtle and a rabbit have to race. The turtle average speed is 0.9 meter per second. So I'm going to say is v for turtle is 0.9 meter per second. What does that mean? It means every second, if let's suppose I say time equal to 0, time equal to 1 second, then time equal to 2 seconds. So really this turtle is going 0.9 meter every second. So let's suppose the turtle start from here, is going to travel from here to there is 0.9 meter. The next second is going to be traveling. So that's what exactly the velocity means. Every second this turtle traveling 0.9 meter. Same thing. And it's gonna go forever because that's the velocity of the turtle. Okay, let's keep continuing. The distance from the starting line, the finish line is 1500 meter. So this total distance is very long, 1500. The rabbit decided to let the turtle run before he start running to give the turtle a head start. What approximately is the maximum time the rabbit can wait before starting to run and still win the race? So rabbit was waiting. Rabbit was waiting, and then to make sure that the rabbit velocity is given, the rabbit velocity I'm going to call E R is going to be 9 meter per second. It means rabbit can travel 9 meter in every second. Yeah. So what we're going to do, we need to find the time turtle take to complete this 1500 meter. So I'm going to say velocity equals to distance, displacement over time, or and then the turtle velocity is 0.9. The time is given is 1500, distance is given, and then time we don't know. So I'm going to call T. TT means turtle, time take by turtle to complete this 1500 meter. So what you're going to do, we're going to take T equals to 1500 divided by 0.9. Let's divide and see what we're going to get. So 1500 divided by 9. And we got here is 1666.6 seconds. Same thing if you're going to take the time for the rabbit. So TR equal to 1500 divided by 9 because the rabbit was running much faster. So what I'm going to do, I'm going to just take this and took the rabbit to him. So now what is the thing is that you have to just take in the delta between the two. So delta t, so rabbit and weight. So I'm going to say 1600. Remember these are second, 6.6 minus 6, 6. And if you just so it's going to give you the answer for if you take the delta, it's going to give you 1500 seconds, and you want to convert the second into minutes. So what you do, we already learned you can take this guy divided by 60. So the answer is 25 minutes. So it's going to take, rabbit can wait until 25 minutes If he wait a little bit longer, then he might gonna lose the race. He has to start running after right around 25 minutes right after when turtle start running. He has to. Okay. We already talked about velocity. Okay. Now, in this course, we're going to be talking about differentiation. So we learn about that is velocity equal to distance, displacement, time. So it's basically rate of change of displacement, right? Velocity is the rate of change of displacement. We can also write velocity equal to limit delta x comes to 0, and then delta x over delta t. Really, velocity can also be written like this, dx. Having said that, we can also say that acceleration can also be written a equals to dv over dt, because acceleration equals to rate of change of velocity. What is velocity? Is the rate of change of displacement. See, this is common. So d over dt is a derivative, and you know the derivative is nothing but is just a rate of change of something to something, and we can write in a differentiation form for that. Okay, instantaneous velocity and speed, we already talked about that. I already told you acceleration can be written like this, v2 minus v1 divided by t2 minus t1, and you can also write like this. But if you want to write on the instantaneous acceleration, you can write like this. Remember, this is average acceleration, and this is the instantaneous acceleration. Okay. Also, we know that acceleration equals to dv over dt, and v equals to dx over dt. So you can write d over t. Inside parentheses, you can write dx over dt. So you can also write acceleration equals to second derivative of displacement, just like this. And what's the unit of acceleration? Distance is in meter, time is squares in second square. So time, the acceleration unit is meter per second. Now, if you remember, we talk about many things. So let me just go to one slide and think about it. We learn about a bunch of things. So first thing we learn about time. Time is t2 minus t1 for time frame. We also talk about distance. So distance could be a distance you travel. It means the total distance you travel. It could not be in a straight line. It could be a straight line, and the unit is in meter. Let me talk about speed. Speed is nothing but its distance over time, and the unit of the speed is meter per second. Then we learn a very important thing called displacement. And why it is very important, because this topic or this chapter, it is start with motion in a straight line or linear motion or kinematics. So this is the key here. Displacement is the basically the origin of this chapter. Motion in a straight line, or you can call it linear motion. Okay. Motion in a straight line, or you can also call a linear motion. Okay. Now, we also learn when event is start, we can call x1, x2, it's the initial position. We also call final position. and the unit of this displacement should be meter, and it's going to be pretty much just like displacement. Distance also in meter, displacement also in meter. Then we're learning another important phenomenon called velocity. And velocity is nothing but v representing by v, and velocity is basically delta x over delta t. You can also write x2 minus x1, t2 minus t1. And we also learned one more thing. This is called average velocity, right? This is called average velocity. If you want instantaneous velocity, you can call instantaneous, or you just don't have to say anything. You just say v means instantaneous. So v means whatever the v, and you can also call dx over dt. You can also write this. Now, the last thing we're learning about there is acceleration. And acceleration is nothing but how fast you change the velocity. Usually we call acceleration. Oh, before I forgot, the velocity unit is meter per second. So you can call meter per second, or you can call meter per second. Acceleration is nothing but is how fast you change the velocity. So you can call it delta p or delta t. You can also write F means final velocity. Final velocity. And minus vi, I means initial velocity. Divided by time, and time could be t2 minus t1 or tf minus ti. You can call it final and initial, or you can call it final as a second position, and initial is position number. Now this is average. If you want the instantaneous, means at the moment, you can call a equals to d v or dt, or we also learned you can replace this d with v with this dx over dt, so you can say d over dt square x. The unit of the acceleration is meter per second, because they have a time square, so you can say meter per second. Now, the most important thing I like to be emphasizing here is Newton. Newton was to understand if I want to talk about, if I'm giving you velocity and if I'm asking about how much time is going to take to complete the event, if I'm going to give you acceleration, depends on what is the final velocity. I can ask you. If I'm going to give you initial time, I can ask you the final time. So basically what Newton was observing is that it's very important when we talk about motion in a straight line. Few things out of these six, right? Few things out of these six given, I'm going to call number one, number two, number three, number four, number five, number six. So these are the six things. In all these six things, few things are given in this certain situation, or few things has to be determined. So we create a standard equation. We create a standard equation of motion. We call it standard equation of motions. Basically, they're helping us to find out time, velocity, acceleration. If I want to do further elaborate more, which time? Initial time, ti, or final time, df, initial velocity, vi, final velocity, vf, or acceleration, like a is acceleration. But we make the assumption in these general equation of motion, acceleration is constant. It means things are keep moving up. Like if things are going, if you throw something up, it's keep going up, slow down, slow down. and come down getting fast, right? Or if you want to drop something from the height, is going to go slow and then really fast. So it means velocity keep increasing, you can call it acceleration is constant. Remember, when velocity keep increasing or keep decreasing, we consider acceleration is constant. Okay, with the same rate. When velocity keep increasing constantly, meaning in the same rate, you can call acceleration is constant. So one assumption before we go into these equations is those equation of motion, acceleration is constant. It means you cannot say acceleration equals to zero. If acceleration is zero, you cannot apply these equation. When you apply this equation, acceleration basically, if you substitute equal to zero, is going to make this whole term eliminated. Okay. So let's talk about this standard equation, and we call equation of motion, and maybe you can call Newton equation of motion because Newton is the one who developed those equations. So that is the first equation. Here you can say acceleration equals to v minus v naught. One assumption you can say here, you never call it v final in this topic or in this book. We can consider v final equals to v. We always call v means final velocity. So one assumption we always call v means final velocity, vi means initial. So this is a final, and v naught means initial. So final minus initial divided by time, same thing, time is t, and initial when everything is start time equals to zero, so you put the zero. If you put the zero, what you're going to do, you take the average acceleration, you can multiply the time. So you can say final velocity here. From here, if I'm going to leave the v, which is my final velocity, so my final velocity equals to initial velocity plus at. I'm going to take this guy on the other side, so it becomes minus becomes plus, and I got this. So this is my first equation. Yeah. The second basic equation is average velocity. So average velocity is change in distance divided by change in time. So you substitute x equals to x naught plus average t, right? And that is my second equation. The third equation we can call it is coming from there is v average equals to v naught plus half at squared. Right? And the fourth equation we use it is x naught minus x naught equals to v naught t plus half at squared. All you have to do is just replace this, changing this with divided by time. So what you can do, just change this guy. V average is to x2 minus x1, or you can say we don't use x2 or x1, we just basically use x minus x divided by t minus 0. So you really left over t. And we substitute here, right? So we're going to substitute here is going to be rid of this guy to x minus x naught over time. We're going to rid of this by x time, and we're going to divide it by everything. We're going to take this the reciprocal and multiply. So x naught over x thing left over here, and we're going to take this t and multiply. So it's going to be t squared. So you can also call it is x minus x naught. You can call delta x equals to v naught t plus half x. So bottom line is that we have three equations right now. Equation number one, equation number two, equation number three. We we are going to use these equations to solve problems of motion in a straight line. Okay. Thank you for watching Knowledge Academy.